All right, let's lay out our PCB now that we've got a schematic. We're just going to double click on this and we'll get a empty board here. The first thing we're going to want to do is we're going to want to go into the page settings, because keyboards can be bigger than this size. So I like to go with like A2, which gives us plenty of space for, a normal sized keyboard, right? Now I'm going to click this button, which is update the PCB with changes from the schematic. So basically it's going to pull in all the stuff from the schematic and update the PCB. I don't know why there was existing errors there. It doesn't make any sense. All right, so we're going to put this down here. Oh, we're missing something. That's actually good. This is a good example. What we're missing is the black pill footprint. And it's probably because the footprint here is not exactly the same name. Let's pick it. Yeah, footprint library not found. Let's fix that, right? So we did add the black pill, and it probably just has a different name, right, than what I used initially. Like this, like I might have named it black_pill or something like that. So this is how we fix that problem. We just go into the schematic editor and we edit the symbol, and then we're going to just update the footprint real quick. All right, so now we know. I'm going to hit save. And now if I go and update the PCB from the schematic, what happened to my... Oh, duh, I'm looking at the wrong thing. This is the other, this is the wrong thing. Here we go. I was looking for the symbol, it wasn't there. I update PCB. Now we've got our black pill, right? We're going to put this down here for now. Just put it somewhere, anywhere. And leave these barfed up components over here. We'll actually move those into place later. And this is actually, I want to point out, this is like the most critical phase. You got to listen to me. The schematic is just like any keyboard. It's just like any keyboard schematic or any Kicad schematic. There's nothing really that special about it. The way I laid it out is my way. You can do it your own way. But trust me when I say that this part is what's most important, is the PCB layout. We need to set up this board correctly so that we get good analog signals. So let's do that. We're going to click this button here. Or actually, you know what? We'll go to board setup, same thing. And what we want to do is we're going to have some, well, first of all, one of these is like the thickness. And we just want to make sure it's 1.6 board finish. Oh, copper finish doesn't matter. Let's pretend we're doing ENIG, which is the gold, right? Doesn't matter. You can leave that alone. Text and graphics, I believe these are all fine. I'm just going to assume you're going to get it assembled at like JLC PCB and go with their capabilities. And Kicad's defaults are pretty good for those capabilities. There's only one thing you want to change here, and that is so we're not going to use micro vias, so we don't really need to worry about that. But if we go into predefined sizes, let's add some, right? We want to use 0.25 millimeters for like our standard stuff. And then for power lines, we're going to use 0.4 millimeters. And for vias, we always want to make sure that we're going to be using 0.6 and 0.3, right? That should make it nice and small, but it's also well within the capabilities of a site like JLC PCB. Now for net classes, we're going to use, this is actually fine. You know what? We didn't even need to do this. Because we're just going to do everything with net classes. So the net classes sound like they're like this sophisticated electrical engineering concept. They're not. It's just defaults for like whatever widths you're choosing, and it makes it nice because if you've assigned everything properly, when you start drawing a track, it automatically picks the correct width, the one that you want. So let's add a power, and we're going to make that 0.4. And for the via size, I like to use 0.6, but it doesn't matter. You can use 0.8 if you got the room, right? It's just they're easier to fit, and I've never had a problem using vias of this size. And if you don't know anything about vias or keyboard design or any of that, this is your first PCB, they're just little holes that connect. They let you run a track from one side of the board to the other. And we're going to be making a 2-layer board. So now we've got default and power, and this is going to work for just about everything. In theory, you might want to use like a little bit thicker trace for your analog traces, because then you will get a little bit less signal loss. But from a keyboard perspective, it's not going to matter that much. There's also a trade-off where if you make it a little bit thicker, it just means there's that much surface area to be act as an antenna, right? And we don't want that. We don't want our traces to ever act as an antenna. So this is really all we need. We want like a thick trace for power, and then for everything else, it can be pretty much the same. You don't have to worry about it. 0.25 and 0.4 is plenty good enough. Let's keep things simple. Now let's do a net class filter. So let's do the power. We're going to want to do power for 3.3. We're going to change this to power. And then for everything else, like AM whatever, let's just do AM and hit enter. Oh, there we go. And we can assign a new net class default. I guess default is fine for everything else. Oh, there was another one. Let's go with power GND. Actually, let's just click the show all nets button. I never go into this thing. Where is our ground power? We're actually not going to really use this, but let's assign it to power. It's alphabetical. I'll just go down to GND. Assign this to power. And I think we're good. The rest of these, you're not really going to use them. We do have to worry about these, the USB-D plus and USB-D. Oh, you know what? We don't. Never mind. Because that's going to be on the microcontroller itself. They're just global labels. We don't even need to worry about it. Sorry. Never mind. Carry on. This is also power, since I'm looking right at it. Though it doesn't really matter. We're not going to connect anything to it. All right, now let me show you what that means. So let's find one of these pins that is ground, or 5 volt. Actually ground, right? So see up here, it says use net class width. Now that I've assigned that to power, what's going to happen is it's going to make a nice thicker trace, or it should. I'm just going to leave that there. And then if I click on this power sense line, right, see how it's thinner? It's using that 0.25 millimeter trace automatically. Right? So that's all that is. That's all that means. So now that we set up our net classes, let's fix the user grid, which I'm looking at right now, and I'm going, oh, that's not right. So normal keyboard spacing, like the space between keys, is precisely 19.05 millimeters, right? But we don't want that because some keys are like 0.25 of that. So the simplest way to do that is to just type 1905 divided by 4. Or if you want a little bit finer control, you can go with that, like 8. I usually go with 4, 19.05 divided by 4. And there we go. So that's now our user grid. And this will make a lot more sense when I import our footprints. Where the heck are our footprints, by the way? I think we have a problem here. So this is void switch 1U, but I bet, see how it says void underscore switch? I think I named the library. Yeah, it's void switch all caps. No? What did I call it? Let's fix it. We'll rename it this. Rename it void underscore switch to fix this problem. So we'll go to our symbol libraries and we put it on the project. What the heck happened to it? Well, that's weird. Anyways, let's add our Kicad symbol library. Where is it? It's not here. All right, let's investigate. All right, I think I figured out what's wrong. I thought that if you just name the library to match, that it'd be fine. So let me show you what I'm talking about. So I thought that if I renamed this to void underscore switch, that would solve the problem. But the problem is actually the name of the file itself, right? So basically, this is my fault, and it's a bug in the tutorial source files. So what I will do is I'll go back and fix that. But let me show you how to fix a problem like this. The reason why change symbol isn't working is because this symbol doesn't actually exist. Like, it can't find it. It's not doing a text-based search. It's actually looking for anything that actually has the symbol, which actually it can't find, right? So since it can't find it, it can't change it to something else, right? So what I'm going to do is, this is what you do. Close this, discard changes. And one neat thing you can do with Kicad is you can edit in a text editor. There we go. That'll work. So we know the bad symbol name. We're going to do Control R, and this is just whatever text editor you're using. And I'm going to search for anything that has this, right? And I'm going to replace it with this, which is the correct name, right? So I'm going to say replace all, 208 replacements made, save. And now I'm going to open it up. And if we look at one of these void switch symbols, and I click on it, look at that, it found it, right? Now I'm going to hit OK, save that, and let's go back to our PCB, and we'll import this. And now we've got all our symbols, which is what was missing before, right? So a little bit of Kicad troubleshooting for you. You can always just go and open the text files and screw around there. So you'll note that none of these are in where they're supposed to be, right? But that's basically the case. That's always the case for Kicad, is when you do that initial import of all the footprints, they're all just, it just barfs them out, a giant mess like that. So now it's our job to actually position them. And this is the tedious part. Probably going to fast forward through this so you don't have to worry about it. But let's find our escape key. Where is it? I might have to search for it. 0 up, because we want to start in the top left. Seriously, where is it? Ah, there we go. So we're going to move this one. And I'm just moving it around, right? But notice that I've got this grid up here, 2.54. If I did that, placed it, and then I changed, I'm going to hit N to go all the way, N, all the way down to the user grid. And that's the N key that lets you shift. And shift N goes backwards, N goes forwards. So now I've got my user grid. If I try and place another another number right next to this, another footprint, I should say. Let's grab 1 because that's where it's going. You see, it's not going to line up right. You see that? That's because when I placed this one, I didn't have the user grid selected. I had something else. Right? But if I have the user grid selected, and now I move it and I place it somewhere, see these little dots? See how it lines up with the dots? Right? Let's go up near the top here, not quite the top. Right? I'll place it there. Now I can move another footprint and it should line right up. You see that? See how it's perfect alignment? The lines overlap perfectly. Now, whenever I grab any other symbol and move it into place, it works perfectly. Isn't that nice? So that's a little tip for you, because a lot of people that have tried, I've been working on this tutorial for a while, but other people are working on their own PCBs based on the source files. They were wondering why it was so hard to align things. Well, now you know. That's why it's like that. And let me give you an example here. Let's place the escape key Hall effect sensor, right? But before we do that, we actually need to go in here. There is one thing we want to change, and I forget where it is, but there's a setting that lets us set the default rotation percentage amount, and it's like, by default is 90 degrees, but we want to be able to do 45, and I'll explain why that is in just a moment. It's not this one. Ah, here it is. Step for rotate command, 45. Let's change that to 45. And you'll see why in just a moment. All right, so now when we rotate something like this one, I'll move it over here. It'll do 45 increments instead of 90. Right? But how do I find which one of these we've assigned to the escape key, right? It seems like be impossible we'd have to move them all out and it would take forever. But there's actually a quick way to do that. We just go and click on escape here. It'll now be highlighted in the PCB. You see that, U2? Now we're going to move it over here to our escape key. And see the center point here? See that little dot? That's the center point, this crosshair. We want to align that crosshair with this little circle. That's what this void switch footprint is for. It's not just to lay out your keyboard. It's also so that you can line this up. But you'll notice there's no way with the user grid to get it in the right place. So what I'm going to do is I'm going to hit Shift N to go back a bit. Just a smidge is all you need. So let's say I'm all the way in my user grid. If I just hit Shift N once, I've got I don't know if you can see that, 0.01. You probably don't need to get to that level of fine detail. So I usually go back a little, like 0.1. No, that's not enough. 0.25, that's probably enough. Nope, apparently we do need 0.1. So we want to zoom out a little bit so we can get the, see the crosshair? Simplest way is just get it close enough. It's not going to be perfect. Close enough, that's like right there. Right? But just know that where we put it now is where we're going to be putting it everywhere else. I'm going to rotate it a little bit. It could be this way or that way. It doesn't matter. It's up to you. I like to have the ground pointing up just because no logical reason. It's just can go either way. Just seems naturally that's where it wants to be in my head. Also, see this U2 and this GH9, whatever. You can either go away or just turn the f.fab layer off. Yeah, now it's gone. See that? Now it's not annoying us being in the way. And this itty bitty circle represents the center of the magnet, and this larger circle represents the actual magnet. That's a 4x2mm magnet. We're talking about a 4x1, or it's a 4mm diameter circle, right? So now we have our switch in alignment. So this is going to be the center of the switch, right? And this is where the magnet needs to be to get the best sensitivity for a Hall effect sensor. Now, to position the rest of these, what do we do, right? Well, first I'm going to hit save. Let's go and click on 1. Get that one highlighted. 1 is U7 for some reason. Kicad's orientation is weird. So we can try and do this like every single time, but that's annoying. A much better way is to just place it over the existing sensor. Let's change our grid. Actually, we'll go all the way to user grid, right? So that way it's all messed up, right? But since we've got the center selected, we should be able to line it. See how it drew that circle there? That means it's centered over this, so they're in the exact same spot. Now I'm going to hit Shift M for move exactly. And I'm going to move it 19.05 millimeters. Bam. Now it's in the right place. Now what's cool about this is if I go to the schematic for 2, right? Let's do this again. Same thing. I'm going to rotate it once. I already hit R to rotate. Let's go over here. And we're going to put it down. Now we should hit Shift M, and it remembered the value. So all we have to do is Shift M and then Enter, and we're good. And we can continue this pattern all the way across our keyboard using whatever layout we want. Now the place where it gets a little tricky is something like 1.25 or 1.75. Now let's find tab, right? So I made them all 1U, right? But that makes it a little bit harder to align. So for those few keys that are a little bit bigger, we want to change the footprint. And we're going to do that in the schematic editor. But let me find tab real quick. Where the heck is it? Tab, 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 tab. Not seeing it. Ah, here we go. So let's move this over here. Move it into position under escape. Now that's not really where tab goes. It's going to go, to the right a little bit. But how do we get it there? How do we know that that's the right place? The way we're going to do that is we're going to go over to our schematic editor, and we're going to change this from 1U to the 1.25U, or sorry, 1.75, which is what a normal tab key is. I think. Let me double check that. Well, sorry, it's 1.5U. I'm glad I double checked. It's 1.5U, so let's fix that. Tab key is 1.5U, which is right here. Hit save. All right, and now I'm going to go back here and I'm going to say update PCB. See how it's a little bit bigger now? Now, if I click on this and I move it, sometimes it's not in perfect alignment. So in those cases, you just need to do something like Shift M, right? And you might need to do this like divided by 8 or like negative to just nudge it in the right direction. But it's always going to be one of the, like some multiple of 19.05 divided by 8 for future reference. So that's how you know. And let's grab the compose key, also known as caps lock. But I wouldn't recommend using a caps lock key. I recommend making it compose. What did I call it? I called it, actually, this is probably the faster way to do it. Go into the schematic editor, click on it, and then you'll get the right one. Just like we are with the Hall effect sensors. So we're going to put this down here. And see how it's like, if I set this to, what is it going to be? 1.75U, right? Let's add that, fix it. 1.75. Okay, hit save, and then let's update this symbols, update the footprints. See how it doesn't line up? This is what I was talking about. So, 1.5 is nice and easy. It falls into our grid. But if I move this right, it doesn't line up. You see that? So what I'm going to do is I'm just going to get it close, and then I'm going to nudge it. I'm going to say 19.05 divided by 8, and that's going to move it just to the right a little bit. Voila. And that's how you fix that. And the same is true for when you're moving the sensors. All right, so if I go to the caps lock sensor here, let's move that one into place. So we don't want, how am I going to get it lined up? I don't want to have to do that thing for every row, right? So what we're going to do here is we're just going to rotate it like normal, put it into alignment. Oh, I grabbed the wrong thing. So if that ever happens where it's like, it seems to have selected from the corner, like if I move here and it's not quite centered, you can just, place it somewhere and then put your cursor close to the middle and hit M again, and then you'll get the center. All right, so let's move this one. We're not going to move it anywhere on the X this time. We're going to move it down. We want to move it down 2 rows. So 19.05 divided by 2, right? So now it's 2 rows down in the exact location it needs to be. And now we just need to move it over a bit. And I'm just going to guess and say that needs to go over a bit. by 19.05 divided by 4. Nope, I was wrong. So now we need to nudge it a little bit more. There you go. And that's how you align these things. And it is pretty tedious. So I'm going to take care of putting a normal looking keyboard layout here and be right back. While I've been working on this, I just realized, and I've only been working on it for like 5 minutes. So I did all this in like 5 minutes. It didn't take that long, right? The part that takes the most is like lining these up and then drawing the tracks. This doesn't take that long, but I realized something. I actually made something to make this part easier, and I totally forgot. So if we go into our footprints here, we search for void, I made a bunch of layouts. So since we're making a 65%, let's grab that 65% footprint that tells us the widths of everything. Our TKL full size, right? So depending on what you want, I've already got a footprint for it. So let's grab 65%. And what I'm going to do is I'm just going to lay it out right on top here. Now you can see it lines up. And then when we're done, we can just delete it because it's just, and it's only on like, I think Eco 1. Oh, yeah, Eco 1 layer. No. Eco 2. No. It's on one of these layers. User 1 maybe. Yeah, it's not on a real silkscreen layer or anything that's visible normally. So it wouldn't show up in your PCB when you get it made anyway. So now we've got that big footprint that has an actual layout, and it should be easier to lay things out. So like I just threw this delete key over here, but obviously it's not in the right place. I can move it over, right? And now when I go to the shift key, the right shift, I know that it is a 1.25 R shift, right, for that one. Well, that's not right. Oh, I'm looking in the wrong place. It's 2.25, duh. So it's a 2.25U shift. So if I go over here and I hit edit, I can fix that. Say 2.25U. Okay, save, update, PCB. So see how it says delete footprints with no symbols? That's handy. And I'll show you what happens there if I do that. If I say update, bam, you see that in the background, that footprint that we just added went away. That's because it's not associated with a symbol. And that's what would happen if you just added these void switch footprints directly to your PCB without actually having this associated symbol. And we don't want that, so let's go undo. And for now, we're not going to delete them. We're just going to update without it, right? So now our R shift should be the right size. Look at that, it's a little too off, so we got to do our little nudging. 19.05 divided by 8. There we go. Now it's in the right place. And I will continue and be right back. All right, I've completed laying out the keyboard keys, all the void switch template files. So now I need to go and add all these Hall effect sensors. And this is basically the same process. It takes somewhere between 5 to 10 minutes to lay them all out. And I already showed you how to do that. But before I continue, I just want to talk about one thing I just thought about. And that is, notice how I've got a couple different keys here, a little bit different normal layout than normal. And this is just my personal preference. And since I'm the creator, I get to, force that upon you. And that is to have 2 space bars instead of 1. And hear me out for a second. So when you have 1 space bar, you have no options. And chances are you only use like 1 thumb for most of them, probably your right, as like that's the most common. Most people use the right thumb to press the space bar. And it's basically a huge ass waste of space, in my opinion. So what I like to do is add 2 space bars, because in the worst case scenario, you can just use both of them as a space, right? But as a better option is you make the left space bar a backspace key. And it's a little bit more convenient than actually like reaching up here and hitting this with your pinky to backspace. You can just hit space with your left hand and it backspaces. It makes a lot more sense from a logical standpoint. Another thing I like to do is a lot of keys have FN keys. A lot of keyboards have FN keys. What a wasted opportunity. It's short for function. But if we have enough letters to spell out escape, something like ESC, then we have enough letters to put fun. Why have an FN key when you can have a fun key? So, and I put my fun key over here. And why have just a little bit of fun when you can have a lot more? You can have more fun, right? So we get 2 function keys with this layout that I've come up with. Other than that, it's pretty much a standard 65% layout. It's just got a few, like 3 extra keys down here, and that's where that comes from. And I find this to be vastly better than your standard long ass spacebar and 1 boring FN key. Because I don't know about you, but I never use right control or the menu key ever. In fact, I could just get rid of the menu key and it wouldn't even matter, not even a little bit. And one last detail I'd like to add here before I start moving all these Hall effect sensors into place is the black pill board is kind of how do I say this? It takes up some space, right? So if we put it up here, and we draw our outline of our board like I did on the tutorial. It's basically wasted space up here. Now, normally what I do is I break out all these extra pins and then set up headers over here so I can use them for things like hooking up relays, fun stuff, sensors and things like that, a lot of quick connector and all sorts of fun things. And I'll try and use that space efficiently, maybe even put a buzzer up here, but it's really not necessary. If I go ahead and move this down here, and by the way, the USB port is the opposite of the, so these are the ST-Link headers down here. The USB port's going to be up here on that side for reference. So wouldn't it be nice if we could just squeeze this in here, right? Instead of having it take up all that space. You can do that. Like, there's nothing stopping you. Just put it here and then move these keys a little bit out. Actually, let's do our user grid. Oh, wrong way. And then. So let's just move these out just a smidge. Actually, we can move them in a little bit. See, now we've got room for our black pill to be there. And now we can make our board nice and tight and concise. And we've even still got room down here for something like a buzzer. And now that I've laid this out, I can get rid of this big or larger footprint. We don't need that anymore because it's all laid out. Delete. See that? So yeah, and we can move our arrow keys. We can do this thing that a lot of keyboards do. Just move it down a little bit. And we don't have to use our user grid for that. I guess we could. Yeah, just move it over a little. Just like that. Give it a little bit of space. We can keep it on the same level. Right, you can do that. And then now you can even turn this arc control into like a slightly longer one. In the menu key. But that's entirely up to you. For this tutorial, I'm just going to put the black pill up top. And for reference, this is not ideal location because it's the farthest away from like the escape key and the control key. So the analog signals coming from these will be a little bit lower than everything else. But it doesn't really matter. My firmware is awesome. It'll deal with it. Don't even worry about it. If you need to run a long trace for an analog signal, it's okay. My firmware will figure it out. It automatically calibrates, takes care, it works around things like that. You don't have to worry about it so much. So that I would recommend putting the black pill there, but that's just me. If you wanted to do it your way, do it your way. And then a future tutorial, we're going to skip the black pill and we're going to use we're going to basically take the same microcontroller off of this and just put it right in the keyboard. And when we do that, we can put it up here in just a very thin layer, or we can put it in the corner. But I'm also the plan here, the big plan, is to put a rotary encoder right here. And we can't have a microcontroller over here if we've got the rotary controller here. Make it like my Risky Board 70 if you guys have ever seen that. I've got a nice big Oreo cookie over here in the corner. That's my rotary encoder. Lets me scroll, control volume, lighting, stuff like that. And eventually I'll have the firmware so you can control the actuation distance with that rotary encoder as well. So that's my little thing that I wanted to cover before I finished laying these out. All right, I'll be back in a bit after I've placed all of these Hall effect sensors. Before I forget, I told you that I was going to tell you why I rotated these 45 degrees. Well, here's why. Let's pretend we're going to put some LEDs on this thing. WS2812 is what I like to use. So we'll just use this one, 2812B, and we'll rotate it. And let's try and place it. Well, let me just put it right here real quick. And then I'm going to rotate these so it's how it was originally. This is its original rotation. Now let's try and put an LED next to it. How do we do that? So the LED has got to be centered on this. You can see the pad overlap. Well, what if I rotate the LED? Right? Now it kind of fits, right? But this overlap with the margin right? So, oh, sorry, the courtyard. So it will bark when we do our DRC, saying that the courtyards overlap with this sort of layout. So in theory, it might kind of work, but in reality, it's not going to. So what we do here is we just rotate this 45 degrees, and now we don't have any overlap. You see that? Everything's just fine. They're close enough. They're far enough away that they're not going to interfere with each other with the when they get placed, but they're still far enough away. They're close enough that everything's centered and where it's supposed to be. So that's why I rotate these in case you want to add LEDs to your project. Nice big ones like the full size WS2012 or the XL one, which also fits because it's just a little bit wider. That's the only difference. And why would you want to use the XL one instead of the WS2012? Because it's cheaper. The WS2012 is kind of expensive, even the clones. But for some reason, unknown reasons, the XL version is like 5 cents instead of 10. It's like half price. So now you know. That's why I have them all rotated 45 degrees, so that you can put an LED in the center and everything just lines up nice and tightly. Okay, I'm done laying out the board. Well, putting all the Hall effect sensors in. That was the last step. Now we need to take care of the analog multiplexers. So let's find AM0. And you can rotate these however you want, right? Experience tells me that having them upright like this works best for this kind of layout. You know, in the past, I've actually had layouts where I did this because it seemed like it fit between these more evenly, but it didn't work out as well as this, honestly. And when we're positioning these, we don't want to use the user grid because we can put them basically anywhere we want. And the key for placement of analog multiplexers is we want them to be as close as possible to the switches that they're going to be connecting to, or I should say that to the Hall effect sensors that they're going to be connecting to. So if we wiggle this around like this, you can see which switches it's connected to. Now, this is because I copied and pasted from my existing example. But if we didn't do that, none of these would be connected yet. And we would, you just have to kind of eyeball it. And you want it to be right in the middle of everything, of all the things that it's connected to. So I tend to put it like right around here, or something like that. Do note, though, that you don't want to get it too close to the sensor itself because you're going to want some space to lay tracks around the sensors. And also, when you're making your keyboard case, you want to leave as much space. Basically, you want to space it evenly between the cutouts that are going to be in the top plate. So as little as possible is like hanging over, like, no, there's no magnets hanging over the analog multiplexer. And it really simplifies things if you try and space it evenly between rows. So ideally, you'd want to put it someplace like this between the, since this is like a longer than normal key, there's letting us space in here for it. But we've got a stabilizer that's going to go right here, and it's going to have a magnet in it too, and over here. So tab is actually a better option since there's going to be no stabilizer. Well, caps is fine actually because there's no stabilizer on caps, but shift would be a bad idea down here. Also, you want it to be as close as possible to the microcontroller as you can as well. So just generally speaking, right around here. Just evenly space it between the, and it doesn't have to follow the user grid, just space it kind of between everything. Give yourself plenty of space between the sensors, just eyeball like right around, we'll say there. I'm not satisfied yet, hold on. There we go, good enough, right? And to simplify your case design, in your OpenSCAD file or your Fusion 360 or whatever you're doing later, you want to make sure that all your multiplexers are on the same exact Y value. That way, when you're designing the case, you don't have to worry about lining them up. If this one's a little bit higher than lower than the other ones, you can just have one Y value for all of them. It really simplifies things a lot. Now let me go back to my 65% and have a look at how I did that. So you can see I placed it just a little bit above the, right in the same spot. Maybe I put it a little bit higher here on the source files. Yeah, you can see I put it a little bit higher, but actually I think this is a better height. I think this is not the ideal location. Maybe I needed it to be a little bit further away from A than it is here. Yeah, see how close that pad is to A? I probably moved it up for that reason, just to give myself a little bit more space. And I like to center it on these lines, but there's no reason to do that. Not really. There we go. Now I've got a little bit more space to route there. And you can see I actually had to route there. Like, there's some, there's plenty of space if I needed to run a route between these two or something like that. It looks like it was a good spot. So I'm just going to keep it. Let's do that. And in fact, if you wanted to, you could just hit edit here. And let's do that. Let's make them all 250.4. Well, actually, this isn't the same location on the board. Yeah, like see, I've got it way down on the side here. So that's not going to work. I can't just copy and paste that value. So I'll just leave it like this. This is good enough. And now let's place the others. Let's go with AM1 is next. And again, it just evenly space it. Just put it around here. And let's see what our value is for Y. And we'll keep it on the same level. And you notice it doesn't have to be perfect. Like the left, right, it doesn't have to be perfect. It just needs to be enough, close enough to all the switches that it's touching, basically that are going to have to go through it. And if you look at my tutorial example, you can see that they're not perfectly evenly spaced, between each other. In fact, this one's kind of off to the side. And the reason why I did that was so that you could make you could add more keys over here if you wanted to, so that way you can just use the tutorial as the basis for some other keyboard, change this to, and then start adding on. Keep things simple for yourself, for everybody else. I try to make it as easy as possible. So that's why I kind of spaced that one out a little bit further than it needed to be. But the rest of them are just kind of like here, there. I just eyeballed it to try and evenly space them. It doesn't matter that much, honestly. So let's do this one too. See how it's connecting to these three, or these all together. I'm kind of glad I copied and pasted from the tutorials, because hooking these, trying to figure out where to run the tracks is kind of a pain in the butt.
Speed.
All right, so that's probably good enough. See how they're just like generally evenly spaced, and that's good enough. And for these screw holes, we'll put them over here. Well, I like to use the user grid for these, actually. So you don't want, so I notice a lot of keyboard makers, when they make their PCB, they'll make the screw hole like right there, right? And this interior box represents 18 millimeters. So we've got the 19.05 spacing, which is this outside white box. And this yellowish color is actually going to be on the silk screen. And if I hit Alt 3 here to bring up the 3D view, you can see that that's going to be the silk screen. And this represents the actual switch body, not the spacing. So the actual body of the switch, the void switch by default, is 18 millimeters by 18 millimeters. And if we put that right there, chances are that the nut, like the M3 nut that's going to come out, is going to stick out into some of the void switch, some of the switch's space over here. And we don't want that. We don't want that at all. So I like to add a little bit of just a smidge extra space. And I think that's one of the big reasons why they use M2 screws, is so they can make things ridiculously tight like that. But let's be honest, folks. Here, you know what? This space here is not, it's not a big deal, right? Sticking out on the sides a little bit or in the back a little bit is not going to make a big difference. Give yourself plenty of space in your PCB design. Give yourself that space. It'll make it so much easier when you're designing the case and when you're screwing everything in to have that extra room. Now, the ones on the interior, we don't have that luxury, right? But for the ones that go in the corners, give yourself some space. Come on, right? That's the way to do it. Let's do H2 here. We'll do the same thing, user grid, but just put it off in the corner here. So this would be where it would go, like here and then over. And we'll just assume that that's going to be the edge of the PCB. And that should give us enough room to put like a rotary encoder here. And we'll do 4 next. Actually, no, 3 would be next. Where's 3? There it is. For this one, if you really wanted to, like, you don't need much space in the front. You could put it right here. But just for consistency reasons, I'll put it there. Give me 4. All right. Now we've got our PCB corners all laid out. Let's put the other ones in the center somewhere. It doesn't really matter where. It's just we're using them to provide center support for the PCB so that we don't flex too much over time. Because vibrations over time can really have an impact. They really can. So we're going to put it down a little bit. I like to put them inwards a little bit, like right along the line here. At the top of a key is great, but at the bottom, see how so close it is to the Hall effect sensor? We don't want that. So if I have to put it here, I'll move it down a bit. But otherwise, I like to put it on the the cross sections between the two here. That's actually not a bad spot right there. We'll do 6 next. We want, and the reason why we're doing it like this, for reference, is like, why is it here and there and not in the perfect center? It's because not many people have a 3D printer that can print an entire keyboard case across the side, the whole thing. In fact, let's move this one over a little bit. There. Right, so it's the approximate center. That way, when someone's printing out in halves, this half will have the screw hole in it, and the other half will have its own screw hole. That way, we don't have to like cut it in half. We're not doing much trouble when we're printing things in sections. Now let's take 6, 7 rather, and space bars usually have plenty of space around them. So I'll just move this one. So you can't. It's kind of annoying that we can't keep them lined up because it'd be too close to that Hall effect sensor. So I'll move it over just a smidge. Yeah, it's kind of close. Go right there. That's fine. It doesn't matter. It doesn't matter that much. There's plenty of room in the case for like M3 screws. And for this one, we'll do the same thing right around here. Yeah, that's good enough. Now we can draw the outline of our board. But before we do that, let's move these fiducials. Just put them over here somewhere, like line that up there, 2. And we don't want it to be in the, see, one mistake would be to put it right exactly in the same spot on this side. We don't want to do that. So instead, we're going to put it like right there. And then for the bottom one, it doesn't matter, anywhere around here is fine. Just remember, you don't want it to be symmetrical. So like we'll put it like here. That way we can draw a triangle that's not perfectly symmetrical, but it covers the majority of our board. I'm also going to move our black pill. We don't need to use our grid for this. We can just put it wherever. Oh, and another thing I like to do is I like to find the center of the board. So what I'll do is I'll just put my user grid, and I will draw it from the screw holes over here. Why is that not? Oh, there we go. So we're 323.850. So 161. So we'll just say 162 would be the halfway point. Right around here. So we'll say like the middle of this J is the center of the keyboard. And I'm going to draw a line right there just to mark it. I'm actually going to edit this. I'm going to make sure it's on a layer that's not used by anything, right? And now I want to find the halfway point from the top and the bottom, but we'll do that once we've placed our black pill, right? Because we want our USB port on the black pill, which is on this side, to be kind of in the center, right? So it doesn't matter that the black pill itself will be off by a bit, and we do want a little bit of space between like the top plate and the black pill itself. So put a little bit of room there, just so that we can put, if we need to, we can put some plastic between them. And we're obviously gonna need to move these screw holes up a bit. That way we can put like a little wall of plastic here. Or the headers itself, they'll stick out a bit. And our top plate, we can pull it off without having it get caught on the black pill. Trust me, I learned this mistake. I learned this lesson the hard way by making that mistake. We'll do this together. And we'll deal with these little resistors, these pull-up resistors later. We'll just leave them there for now. All right, the majority of our keyboard is actually laid out pretty well. And anyone that's made a keyboard before is going to know pretty much what to do at this point. They're going to draw the edge cuts around it and start connecting up all the this rat's nest. Okay, that's a good stopping point. In the next video, we're going to do more of the PCB layout. Hopefully we'll be able to finish it, but no guarantees. We're going to be hooking up the analog multiplexers and go on from there. So see you in part 3.